Hi everyone! So today we're going to talk about our next topic, which is pH indicators. Our main goal today is to be able to read table M in your reference table, so you need to make sure that you have a reference table to look at it. You can either find your physical copy or look online, but I would prefer you to have a physical copy in front of you. We're going to start with a do now, which is based on our last lesson, so you might want those notes available to you. We're going to talk about what indicators are, and we're going to do a couple practice problems. So starting with a do now, we're going to complete the following 5 questions in your notebook. You're going to do it, and then I'm going to go over it on the next slide. But on the side here, you can see these 5 substances ranging from battery acid to vinegar. All of these have different pHs. They range from acidic to basic, and you're going to place them on a pH scale. So what I would like you to do is draw a pH scale. Place these 5 substances on the scale as close as you can get to their expected value. These are substances that were in the last set of notes at the very end of the video, or you can Google their pHs. After you finish with those values, I would like you to identify which of these 5 substances have the highest concentration of hydronium, which of them have the highest concentration of hydroxide, which one has the same amount of hydroxide and hydronium, and lastly, identify a substance that completely dissociates. There's 2 answers. Picking just one will be fine. So please pause the video and complete this in your notebook before moving on. Alright, so here's the answers to the do now. Here's my pH scale. I went from left to right. It's fine if you went up and down or made a different kind of scale. But things that you should have is, 1, you should have a scale of 0 to 14. pH ranges of 0 to 14. A reminder that anything under 7 is acidic. Anything over 8 is alkaline or basic. And a pH of 7 is neutral. Here's our substances ranging from most acidic to most basic: battery acid, vinegar, water, ammonia, and lye. On to the question. So number 2 asked which of the following substances produces the most hydronium. So a reminder that hydronium is another way to say a proton. The substances that produce the most protons are the most acidic. So out of these substances, battery acid is our most acidic, so it produces the most hydronium in solution. Number 3 follows the same type of logic. So this time we're looking for the substance that produces the most hydroxide. The most basic substance is going to produce the most hydroxide, so in this case, that would be lye. Number 4 asked which substance has the same amount of hydroxide and the same amount of hydronium. When you have equal amounts of hydroxide and hydronium, you have a neutral solution. And our main example for that is water. And lastly, number 5, which substances would completely dissociate in water? So strong acids and strong bases are going to completely dissociate. So on this scale, that would be battery acid and lye, our strong acid and our strong base. So our new topic we're covering today are indicators. Indicators are chemicals that change color within a certain pH range. So drawbacks to indicators is it only provides a pH range that the solution can fall into. Outside their pH ranges, indicators aren't that effective, so it's important to already know if a solution is acidic or basic. You're really just trying to narrow it down. If you want an exact pH value, you would have to use a pH probe. We may be doing a lab on that later. If you don't already, please take out your reference table because you're going to need table M for the rest of the video. But this is table M, our common acid and base indicators. There's quite a few more acid-base indicators out there, but like the table says, this is the most common. We have methyl orange, bromthiamyl blue, phenolphthalein, litmus, bromcresol green, and thymol blue. So those names are a mouthful, but here we have our indicator. We have the range where it's actually useful and the color change you can expect in that range. I'm going to go to the next slide and show you exactly how to read each line for table M. Alright, so focusing in here, so for example, we have indicator methyl orange. So when I'm using an indicator, I'm going to have my solution and I'm going to add said indicator to the solution. When I do that with a solution inside this pH range, 3.1 to 4.4, I can have pretty much three things happen. The first is that the pH of that solution is less than 3.1, and that would be indicated by a color change to red. So the first number corresponds to the first color. pH less than 3.1, you get a red solution when you add the indicator. My second option is the pH of the solution is somewhere in between 3.1 and 4.4. Let's say a pH of 3.6. If my solution has a pH of 3.6, you can get orange color, somewhere between red and yellow. My third option is my pH is greater than 4.4, exactly 4.4. In that case, my solution, when I add methyl orange to it, is going to turn yellow. So again, the first number corresponds to the first color. The second number corresponds to the second color. Alright, let's do another type of question. So here we have identify the pH range of a solution. So I inserted a couple pictures here. We're going to imagine that in this beaker and in this Erlenmeyer flask we have the same exact solution. And we're doing two different pH tests. The first we're doing phenolphthalein, second we're doing thymol blue. And we're going to identify the range this solution's pH falls into. So in the Erlenmeyer flask we have the solution, phenolphthalein has been added to it, and it turned pink. So we go over to table M, find phenolphthalein. We see that when the solution turns pink, it has to be at a pH of 9 or greater. So that's the start of our pH range. We do another test on the same solution, adding thymol blue, and we see it turns blue. So we go to thymol blue. We see it turns blue at a pH of 9.6 or greater. And based on the information we have, our pH range is 9 to 9.6. Here's a practice regions question. So which solution below, when mixed with a drop of bromthymol blue, will cause the indicator to change from blue to yellow? So I'm going to immediately go to table M before I even look at our options. Find bromthymol blue. And this indicator changes from blue to yellow. So if we're going from blue to yellow, we're going from a pH of approximately 7.6 to 6 or lower. So if we're going lower on the pH scale, I have to be adding an acid. So which of my answer choices corresponds to an acid? If we take a look here, the one that's an acid is A. And again, I know that because it's starting with H. If it ends with OH, it's a base. Ammonia is our other base that you need to know, which you can also look up in your reference table. And lastly, don't be fooled by choice D. This is just a covalent compound. It will not dissociate in water, so it is not a base despite the fact it ends with OH. Alright, and here's our last practice question for this video. Pure water containing phenolphthalein will change from colors to pink with the addition of. So again, I'm going to go to phenolphthalein. I see that anything under a pH of 8 is colorless. the solution is turning pink, which means it needs to get to a pH of 9 or greater. Which one of the options will make our pH basic? KCl? Don't think so. It's a salt. HCl, this is an acid, so our pH would go down if we add this. HOH, another way to write water's formula, H2O. We have H plus and OH minus in equal amounts. This is neutral. It'll do nothing to our solution. And lastly, KOH. KOH is a base. If we add our base, it will become more acidic, making this, or excuse me, if we add our base, it'll become more basic, increasing our pH to 9 so that our solution turns pink, making this our correct answer. Alright, so hopefully you understood the video. If you have any questions, let me know. Otherwise, please go try the Canvas quiz labeled indicator.